Welcome to the weekly deep dive. It is Friday, February 20th, 2026. And if you've been tracking the AWS RSS feeds this week, you've probably noticed a pretty significant spike in activity. We are looking at 78 separate updates today.
Yeah, it really is a dense week. Usually when we see numbers that high, it's inflated by a lot of minor regional expansions, localization updates. And we do have those, sure, but the signal to noise ratio is actually incredibly high this time around.
It really is. And while volume doesn't always equal value, this particular week is just heavy on core infrastructure changes, things that are going to affect how you architect your systems for the rest of the year. We're calling today's theme Heavy Iron and Smarter Agents.
I like that. The core theme effectively boils down to a massive refresh of the compute layer, the actual silicon you're running on, paired with a really distinct maturation of the AI platform, specifically regarding how models are served and fine-tuned now.
Right. We have a full agenda, so let's just outline the path for you. We're going to start at the bottom of the stack with the compute overhaul. So that's the new Blackwell GPUs, the high-frequency AMD processors, and a big strategic shift with the new Flex instances.
And from there, we'll move up to the AI layer. We need to dissect the arrival of Claude Sonnet 4.6, but maybe more importantly, we need to talk about Project Mantle and what it means for your inference architecture, along with reinforcement fine-tuning.
Yeah, and then we'll close out with data and operational tooling, specifically Aurora DSQL connectivity, S3 table optimizations, and a feature in CloudWatch that I think is going to permanently change how on-call rotations manage their maintenance windows.
It's a really solid technical lineup. Let's get into the hardware.
Starting with the GPU news. So the Amazon EC2 G7e instances are now available, launching initially in the Tokyo region. The G series usually implies graphics-heavy or, standard inference workloads. But with the ease extension here and the specs attached to it, this looks like it's targeting a much heavier class of compute.
It absolutely is. The G7e instances are accelerated by NVIDIA RTX Kiro 6000 Blackwell Server Edition GPUs. So this is the arrival of the Blackwell architecture into this specific instance family. For anyone running heavy inference or spatial computing workloads, this is the generational leap you've been waiting for.
Let's talk performance deltas then. We're coming from the G6e. What kind of lift are we actually seeing here?
It's significant. We're looking at up to 2.3 times the inference performance compared to the G6e, and that multiplier is critical right now because of the shift in workload types we're seeing.
Because we aren't just serving simple chatbots anymore.
Exactly. We're seeing a massive rise in agentic workflows models that require multi-step reasoning, planning, tool use. Those inference chains are incredibly compute intensive.
And the specs on the instance itself really support that density, right?
Correct. You can provision up to 8 GPUs per instance with 96 gigabytes of memory per GPU. That provides a massive VRAM pool, so you can load larger models entirely into memory without having to shard them aggressively across different nodes. And they're backed by 5th-gen Intel Xeon processors, so the host CPU isn't going to bottleneck your data feed.
There's a really specific networking detail here regarding GPU Direct as well that caught my eye.
Yes, these instances support NVIDIA GPU Direct peer-to-peer, or P2P. In a distributed training or large-scale inference scenario, latency between the GPUs is the ultimate killer.
Right, because traditionally, data has to travel from the GPU up to the system RAM and the CPU, and then all the way back down to the target GPU.
Exactly. It's a massive detour. GPU Direct allows the GPUs to transfer data directly to each other's memory via the PCIe bus, completely bypassing the CPU. If you're running an 8-GPU deployment, that latency reduction is just non-negotiable.
Shifting from the GPU to the CPU side, AMD has a huge presence in this week's update. Let's look at the M8is and instances. The Z's designation in EC2 nomenclature historically points to high frequency.
Right, and these deliver on that. These are built on the 5th generation AMD EPYC processors, which is the architecture formerly known as Turin. The headline metric here is the clock speed. These cores hit a maximum frequency of 5 gigahertz.
5 gigahertz in a server environment is incredibly aggressive. Typically, server chips prioritize core count and power efficiency over raw clock speed, while consumer chips push the frequency.
Right, which tells you exactly who this instance is for. This is strictly for workloads bound by single-threaded performance. We're talking about high-frequency trading, real-time financial analytics engines, and gaming server backends.
Where single-thread speed is everything.
Yeah. In HFT, the difference of a few microseconds in execution time is actual revenue. If your single-core execution is faster than the broader market, you win the trade.
And what's the comparison against the previous generation? The M5 Zen?
They're citing up to 2 times the compute performance. It's a massive jump for that very specific, highly latency-sensitive niche.
Now, staying with that Turin architecture, but totally flipping the design philosophy, we also have the HPC 8A instances.
This is the exact other side of the coin. While the M8i is all about single-thread speed, the HPC-AA is about density and throughput for high-performance computing. Think computational fluid dynamics, weather forecasting, reservoir modeling, workloads that need to parallelize across massive core counts.
And the specs here are just staggering.
They really are. You're getting 192 cores and 768 gigabytes of memory in a single instance. Performance-wise, it's roughly 40% higher than the previous HPC 7A.
So if you're running a tightly coupled MPI workload like message passing interface to simulate airflow over a fuselage, that 40% performance gain translates directly to faster job completion.
Faster completion and a lower cost to solution overall.
Okay, so we have high-end GPUs, we have high-frequency trading chips, and we have massive HPC nodes. But then we have a totally new concept appearing in Tokyo, Ireland, Paris, and a few other regions, the Flex instances. So M8i-flex, R8i-flex, C8i-flex. What is the architectural strategy behind Flex?
This is probably the most important development for general-purpose compute this week. These are powered by custom Intel Xeon 6 processors. The Flex designation really addresses a hard reality of cloud infrastructure, which is that most workloads are heavily over-provisioned.
Meaning engineering teams buy a large instance for safety and then just let it sit at 20% utilization all day.
Exactly that. Web servers, microservices, CI/CD runners, they often sit idle or at very low utilization with only occasional spikes. The Flex instances are designed to be the new entry point for price performance. They bridge the gap between the burstable T-series and the fixed performance M or C series.
Because the T-series uses that CPU credit model, which can be really complex to manage and monitor at scale.
Precisely. Flex gives you a middle ground for workloads that don't need sustained peak performance but want predictable pricing. They offer up to 15% better price performance than the previous generation. The intent here is really to provide a new default for standard infrastructure. If you aren't running a database that pins the CPU at 90% all day, you should likely be looking at Flex to optimize your bill.
One final hardware update that is going to make virtualization engineers very happy. EC2 now supports nested virtualization.
This is a feature that has been on wish lists for years. Nested virtualization allows you to run a hypervisor inside an EC2 instance.
Previously, this strictly required bare metal instances, correct?
Right. If you wanted to run KVM or Hyper-V, you had to provision a .metal instance, which is a full physical server. That is expensive and usually massive overkill if you just need to run a small emulator. Now, you can enable nested virtualization on standard virtualized EC2 sizes.
What's the primary use case driving this change?
Mobile development and testing is a massive one. Running Android emulators inside a CI pipeline requires hardware acceleration. Automotive simulation is another big one, where you're simulating in-vehicle hardware stacks.
Oh, and developers using Windows workstations in the cloud.
Yes. If they want to use WSL, the Windows subsystem for Linux, that relies on Hyper-V. This update essentially removes a major hardware constraint from the software development lifecycle.
Moving to segment 2, we're looking at the AI layer. The obvious headline is the availability of Claude Sonnet 4.6 on Amazon Bedrock.
Yes, Anthropic describes this as their best computer use model yet. The computer use capability is the key differentiator here. It's heavily optimized for agentic workflows where the model actually needs to navigate interfaces, click elements, and perform tasks directly in a browser environment. It approaches the intelligence of Opus 4.6, but at a much lower latency and cost profile.
However, the broader story on Bedrock this week isn't just Anthropic. It's the influx of open-weight models. We saw DeepSeek v3.2, Minimax M2.1, GLM 4.7, Qwen 3 Coder next. It feels like the platform just completely opened the floodgates.
It did, and that velocity is entirely due to a new underlying infrastructure piece called Project Mantle.
Let's drill into Project Mantle, because this really seems to be the enabler for this massive release cadence.
It is. Project Mantle is a distributed inference engine purpose-built for Bedrock. Historically, onboarding a new foundation model required a fair amount of bespoke infrastructure tuning to optimize inference for that specific architecture. Mantle acts as a standardized abstraction layer.
So it essentially decouples the model onboarding process from the low-level hardware tuning.
In a sense, yes. It provides a serverless inference environment with built-in quality of service controls. And crucially for the developers listening, it ensures out-of-the-box compatibility with OpenAI API specifications.
That API compatibility is a massive friction remover.
It's become the industry standard. If you have an application written against the OpenAI spec, you can now switch the endpoint to Bedrock and effortlessly swap between DeepSeek, Quinn, or Mistral with minimal code changes. Mantle handles the capacity management and pooling in the background. This is exactly why we're seeing such a rapid release cadence for these new models. AWS has built a universal adapter.
On the topic of model customization, there was a highly technical update regarding reinforcement fine-tuning, or RFT, on Bedrock.
This is a major maturity step for the platform. Bedrock now natively supports RFT for select open-weight models, specifically the Qwen 3 32B model and the GPT OSS 20B model.
For those who are only familiar with supervised fine-tuning, or SFT, how does RFT change the training paradigm?
Supervised fine-tuning is about showing the model explicit examples. You say, here is the input, here's the correct output. It mimics the dataset. Reinforcement fine-tuning is fundamentally different. It's about optimizing for a reward signal. The model generates multiple different responses to a single prompt, and those responses are graded. The model then updates its internal weights to favor the behaviors that led to the higher scoring responses.
And the grading mechanism itself, how is that defined?
That's the incredibly flexible part. You can define reward functions using strict rule-based logic, or you can use an LLM as a judge to score the outputs based on nuance. You can even hook up an AWS Lambda function to execute custom grading logic.
Give me an example of the Lambda integration.
Say you're fine-tuning a coding model. You could have the model generate code, pass that code to a Lambda function, which attempts to compile and run it against unit tests, and the model only gets the reward signal if the code actually builds successfully. This allows you to train models for highly specific, complex behaviors using much smaller datasets than traditional SFT requires.
Staying with that agentic developer theme, we saw a tool called Kiro appear in multiple updates this week, touching GovCloud, Aurora DSQL, and Healthomics.
Right. Kiro is an agentic AI tool focused directly on the developer environment, integrating into the IDE and the CLI. It follows a spec-driven development philosophy. You provide a high-level intent, Kiro generates a detailed specification for your approval, and once approved, it generates the implementation code, the tests, and the documentation.
And it seems to be integrating across AWS services via a plugin architecture.
Yes, they call these plugins powers. The update this week highlights new powers for Aurora DSQL to assist with complex schema design and Healthomics for building bioinformatics workflows. Kiro leverages the Model Context Protocol, or MCP, which allows it to contextually understand the actual resources currently deployed in your AWS account. It's moving way beyond simple code completion to full architecture completion.
Let's transition over to segment 3, looking at database and analytics maturity. We just touched on Aurora DSQL, but there were specific updates to make it much more developer-friendly.
Aurora DSQL is their new distributed SQL offering, and they are aggressively tackling the friction of connectivity. They just released official connectors for Go using PGX, Python using AsyncPG, and Node.js.
What is the specific problem these new connectors solve?
Authentication management. Connecting to an RDS or Aurora database using IAM usually involves generating a temporary authentication token, ensuring it's signed correctly, and writing the logic to handle token rotation. It's tedious boilerplate code that can be really fragile in production. These new connectors abstract that entirely. They handle the IAM handshake automatically under the hood.
So no more hard-coded database secrets or writing custom token refreshers.
Exactly. It completely aligns with a secure by default posture. Additionally, they added support for identity columns and sequences to DSQL.
That sounds like a very standard SQL feature. Why is that a headline?
It is standard, but its absence is a massive migration blocker. Many legacy Postgres applications rely heavily on serial types or auto-incrementing integer IDs. Modern distributed databases often strongly prefer UUIDs for scalability reasons. By adding native support for identity columns, Aurora DSQL makes lift and shift migrations actually viable for older applications that can't easily be refactored to use UUIDs.
In the storage world, S3 tables received a programmatic update regarding the Create Table API.
This is a pure infrastructure as code enabler. The Create Table API now allows you to define partition transforms and sort orders at the exact time of table creation.
Why is defining that at creation time so critical for optimization?
It comes down to performance and cost. If you dump data into an S3 table without defined partitioning or sorting, your analytics queries are going to scan way more data than necessary. Previously, setting this configuration might have been a manual second step. By making it part of the initialization API, you ensure that the table is fully optimized for query performance from the very first byte of data ingested via your CI/CD pipeline.
Amazon OpenSearch Serverless also rolled out a feature called collection groups.
This is an architectural efficiency play, particularly for multi-tenant SaaS platforms. In OpenSearch Serverless, compute capacity is measured in OCUs, or OpenSearch Compute Units. Previously, if you needed strict encryption isolation, meaning different KMS keys for different tenants, you needed entirely separate collections, which meant you had to provision separate OCUs for each tenant.
So you were effectively paying for redundant idle compute just to achieve compliance and encryption isolation.
Correct. Collection groups fix this. They allow you to share a pool of OCUs across multiple collections that use different KMS keys. You keep the strict cryptographic isolation between tenant A and tenant B, but they share the underlying compute pool. It drastically lowers the baseline cost per tenant for SaaS builders.
Briefly touching on Redshift and Neptune before we move to operations.
Neptune Analytics expanded to 7 new regions, which is standard global growth. The Redshift update is quite interesting, though. It allows you to allocate specific, isolated compute capacity for autonomics. This means background maintenance tasks like table vacuuming and sorting run on their own dedicated capacity, ensuring they absolutely don't contend with your active business intelligence queries during peak hours.
Moving to segment 4, operational excellence. There is one feature here that I think is the absolute highlight of the week for anyone carrying a pager. CloudWatch alarm mute rules.
Finally, this is a massive quality of life improvement for operations teams.
Walk us through the exact functionality here.
It allows you to create specific rules to suppress alarm actions, up to 100 alarms per rule, based on a defined schedule or a one-time event window.
So perfectly tailored for standard maintenance windows.
Yes. If you have a known database deployment every Tuesday at 2 a.m. that always causes a brief spike in CPU or latency, you can mute the resulting alarms so you don't wake up the on-call engineer for an expected event. But the critical design choice they made here is the safety net.
Right, what actually happens when that maintenance window ends?
That's the key. When the mute rule expires, if the system state is still an alarm, it immediately triggers the action. It doesn't just ignore it or wait for a state change. This prevents the classic outage scenario where an engineer manually disables an alarm for maintenance, forgets to re-enable it, and then the team misses a real catastrophic incident 3 hours later.
That logic alone is worth the update. Just brilliant. Next up, EKS auto mode logging.
This addresses the black box problem of managed services. EKS Auto Mode handles compute scaling, block storage, and load balancing for you automatically. But when things go wrong, or costs spike, you need to know why the autoscaler made a certain decision. This update allows you to pipe logs from the EKS managed control plane directly to CloudWatch vended logs. It provides true observability into the infrastructure decisions AWS is making on your behalf.
We also saw a major compliance win for AWS payment cryptography with Cartes Bancaires.
This is huge for the European fintech market. Cartes Bancaires is France's national card payment network. Achieving this approval means that acquirers, issuing banks, and payment processors can finally replace on-premises hardware security models with AWS cloud services. It removes the need to maintain highly secure physical data centers solely for the purpose of housing crypto hardware just to operate in the French market.
Closing out the specific updates with Amazon Connect, the contact center service.
2 features here. First, audio enhancement. It uses AI to provide deep noise suppression and voice isolation. If you have agents working remotely from home or in highly dense call centers, this dramatically cleans up the audio signal for the customer. Second, AI task overviews.
This is essentially a summarization feature for the agents.
Yes. When an agent picks up a new task, like a customer callback or a complex ticket, the AI provides an instant summary of all previous interactions, like return eligibility, and suggests the logical next steps. It heavily reduces the context switching tax that agents pay when rapidly moving between totally different customer issues.
Looking back at the entire stack this week is just a formidable set of updates. We have Blackwell GPUs and 5 GHz CPUs completely raising the hardware ceiling. We have Project Mantle accelerating the deployment of open models. And we have significant maturity in daily developer tools like Aurora DSQL connectors and CloudWatch mute rules.
It's a week that really highlights the dual velocity of AWS right now. On one hand, they are pushing the absolute bleeding edge of silicon and agentic AI capabilities. On the other, they're methodically fixing the practical day-to-day friction points for infrastructure engineers with things like nested virtualization and Betty database drivers.
What is the one thing the listener should really take away from all this?
I think it's the velocity of model integration via Project Mantle. The fact that we are seeing DeepSeek, Qwen, and others appear natively on Bedrock so quickly after their open release signals a major market shift. The gap between state-of-the-art in the research lab and available as a highly scalable managed API is collapsing. If you are building AI applications today, your menu of options just got significantly larger and much easier to integrate.
It really is a great time to be a builder. But before we sign off, here's a final thought to mull over. With Project Mantle standardizing how seamlessly we can swap out these foundation models and agentic tools like Kiro writing their own implementation code, we're rapidly approaching a point where the infrastructure abstracts away the specific AI model entirely. You have to wonder, when the model itself becomes a true interchangeable commodity, where does your actual intellectual property sit? Is it just your prompt engineering? Or is it the real-time proprietary feedback loops you build into pipelines like reinforcement fine-tuning? Something to think about as you design your next architecture.
Absolutely.
As always, links to every single update we discussed today, all 78 of them, are available in the show notes for your own deep dive. Thanks for listening, and we'll see you next week.